Welcome to Bob's Smart Class, a new smart way to build a bright career. I am Harpreet Singh Kohli, your tutor for Mathematics NCERT Class 9th. This video will explain Chapter 8, Theorems of Quadrilaterals and Parallelograms. Now let's start Theorem 8.1. A diagonal of a parallelogram divides it into two concurrent triangles. This had appeared in 2010 CBSE CC exam. Solution given. We have a parallelogram ABCD in which AC is a diagonal. This diagonal cuts the parallelogram into two triangles, triangle ABC and triangle CDA. To prove these two triangles are concurrent, that is, triangle ABC is concurrent to triangle CDA. Now let's try to prove it. In a parallelogram, opposite sides are parallel. Therefore, AB is parallel to CD. And AC is a transversal, that is, it cuts these two parallel lines. Therefore, angle BAC equals to angle DCA or angle 3 equals to angle 4, which are alternate angles of these two parallel lines and the line which cuts these two parallel lines. Similarly, AD is parallel to BC, which are also opposite sides of a parallelogram, and AC is a transversal which also cuts these two parallel lines. Therefore, angle DAC equals to angle BCA or angle 1 equals to angle 2, which are also alternate angles of these two parallel lines. Now, in triangle ABC and triangle CDA, we have angle BAC equals to angle DCA and angle DAC equals to angle BCA, which are proved above. And we have a common side AC. Therefore, AC equals to CA in these two triangles. Hence, by the rule ASA, which is angle side angle, these two triangles are concurrent. Therefore, triangle ABC is concurrent to triangle CDA. Hence, this theorem is proved. Now next theorem is 8.2. In a parallelogram, opposite sides are equal. Solution given. A parallelogram ABCD. To prove AB equals to DC and AD equals to BC. Construction. We will draw a line AC as a diagonal of a parallelogram ABCD. Now let's prove it. In triangle ABC and triangle CDA, we have a common side as AC. So, AC equals to CA in these two triangles. Angle DAC equals to angle BCA or angle 1 equals to angle 2, which are alternate angles, because AD is parallel to BC and AC is a transversal which cuts these two parallel sides. Therefore, alternate angles of these two sides are equal. Similarly, angle BAC equals to angle DCA or angle 3 equals to angle 4, because they are also alternate angles, as DC is parallel to AB and AC is a transversal. Therefore, by the rule ASA, that is angle side angle, triangle ABC is concurrent to triangle CDA. Now, as these triangles are concurrent, hence AB equals to DC and AD equals to BC because they are the corresponding parts of congruent triangles. Hence, this theorem is proved. Next theorem is 8.3. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Solution given. We have a quadrilateral ABCD in which AB equals to DC and AD equals to BC. These are opposite sides. To prove, quadrilateral ABCD is a parallelogram. Let's join A and C, which produces a diagonal for this quadrilateral, and it divides this quadrilateral into two triangles ABC and triangle CDA. Now let's try to prove it. In triangle ABC and triangle CDA, we have AB equals to DC and AD equals to BC. These are given. And we have a common side AC. Therefore, AC equals to CA. Hence, by the rule SSS, that is, all three sides are equal, these two triangles are congruent. Therefore, triangle ABC is congruent to triangle CDA. Further, if these two triangles are congruent, their corresponding parts are equal. Therefore, angle BAC equals to angle DCA or angle 1 equals to angle 2. But these are also alternate angles. They are alternate angles of sides AB and DC. As we know that if alternate angles are equal, then sides are parallel. Therefore, AB is parallel to DC. And we have AB equals to DC also, as a given in theorem. Similarly, angle DAC equals to angle BCA, which are also corresponding parts of these two triangles, these two congruent triangles. Now these are also alternate angles of AD and BC. If these alternate angles are equal, the sides are parallel. Therefore, AD is parallel to BC, and we have AD equals to BC also, as given in theorem. Now when opposite sides are parallel and equal, this quadrilateral is a parallelogram. Hence, this theorem is proved. Next theorem is 8.4. In a parallelogram, each pair of opposite angles is equal. Solution given. We have a parallelogram ABCD. We have to prove angle BAD equals to angle BCD and angle ADC equals to angle ABC, or angle 7 equals to angle 8 and angle 5 equals to angle 6. Let's join A and C, which produces a diagonal, and this diagonal cuts the quadrilateral into two triangles ABC and triangle CDA. Now let's try to prove it. In triangle ABC and triangle CDA, AC is common. Therefore, AC equals to CA in these two triangles. Next, angle DAC equals to angle BCA or angle 1 equals to angle 2 because they are alternate angles of parallel sides AD and BC. Similarly, we have angle BAC equals to angle DCA, which are also alternate angles of sides DC and AB. Hence, by the rule ASA, that is angle side angle, these two triangles are congruent. Therefore, triangle ABC is congruent to triangle CDA. Now, if these two triangles are congruent, their corresponding parts are equal. Hence, angle ADC equals to angle ABC, or angle 5 equals to angle 6. So, one of the opposite angles is equal. Now let's try to prove angle BAD is also equal to angle BCD, which is the other opposite angles of this quadrilateral, or angle 7 equals to angle 8. Earlier we have that angle 1 equals to angle 2 and angle 3 equals to angle 4. And we can see that angle 1 plus angle 3 is equal to angle 7, and angle 2 plus angle 4 is equal to angle 8. So if these two subsets are equal, then the whole angle is also equal. Therefore, angle 7 equals to angle 8, or angle BAD equals to angle BCD. Hence, we have proved that each pair of opposite angles of a parallelogram is equal. Hence, this theorem is proved. Next theorem is 8.5. If in quadrilateral each pair of opposite angles is equal, then it is a parallelogram. Solution given. A quadrilateral ABCD in which angle DAB equals to angle DCB and angle ABC equals to angle CDA. We have to prove this quadrilateral ABCD is a parallelogram. Now let's try to prove it. In a quadrilateral ABCD, sum of interior angles is always 360 degree. Therefore, angle A plus angle B plus angle C plus angle D is equal to 360 degree. But angle A equals to angle C and angle D equals to angle B, which are given in this theorem. Thus, we can replace angle C with angle A and angle D with angle B in earlier statement, and we will get 2 angle A plus 2 angle B equals to 360 degree. Further, angle A plus angle B equals to 360 degree divided by 2, which is equal to 180 degree. But on the other side, we have angle A and angle B, which are interior angles on the same side of transversal AB. This transversal cuts lines AD and BC. Therefore, side AD is parallel to side BC. Similarly, we can prove AB parallel to DC, as we can replace angle C with angle A in earlier statement, having angle B plus angle C equals to 180 degree. And also angle B and angle C are interior angles on the same side of transversal BC, which cuts lines AB and DC. Therefore, side AB is parallel to side DC. Now, if these two if these two opposite sides are parallel, then this quadrilateral is a parallelogram. Hence, this theorem is proved. Next theorem is 8.6. Diagonals of a parallelogram bisect each other. Solution given. A parallelogram ABCD in which diagonals AC and BD intersect each other at point O. We have to prove OA equals to OC and OB equals to OD. Now let's try to prove it. In triangle AOB and triangle COD, we have angle AOB equals to angle COD or angle 3 equals to angle 4 because they are vertically opposite angles. And AB equals to CD because they are opposite sides of a parallelogram, which are always equal and parallel. Next, angle BAC equals to angle DCA or angle 1 equals to angle 2, which are alternate angles of the transversal AC, which cuts the two parallel lines DC and AB of this parallelogram. Therefore, by the rule AAS, that is angle side rule, these two triangles are congruent. Therefore, triangle AOB is congruent to triangle COD. Hence, by the rule of corresponding parts of congruent triangles are always equal, so we will have OA equals to OC and OB equals to OD. Hence, this theorem is proved. Next theorem is 8.7. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Solution given. We have a quadrilateral ABCD in which AO equals to OC and OB equals to OD. We have to prove this quadrilateral ABCD is a parallelogram. Now let's try to prove it. In triangle AOB and triangle COD, we have angle AOB equals to angle COD or angle 3 equals to angle 4 because they are vertically opposite angles. And we have line AO equals to line OC and line OB equals to line OD, which are given in this theorem. Therefore, by the rule SAS, that is side angle side rule, these two triangles are congruent. Therefore, triangle AOB is congruent to triangle COD. Hence, if these two triangles are congruent, then their corresponding parts are equal. Therefore, angle ABO equals to angle CDO or angle 1 equals to angle 2. Now, if angle 1 equals to angle 2, they are also alternate angles of the transversal BD, which cuts lines AB and DC. Thus, we can say that line AB is parallel to line DC. Similarly, we can prove BC parallel to AD by proving triangle DOA is congruent to triangle BOC and then deriving angle DAC equals to angle BCO, which are alternate angles of the transversal AC which cuts lines AD and BC. Therefore, BC is parallel to AD. Now seeing this, that these two opposite sides are parallel, then this quadrilateral ABCD is a parallelogram. Hence, this theorem is proved. Next theorem is 8.8. A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Solution given. We have a quadrilateral ABCD in which AB is equal to CD and AB is parallel to CD. We have to prove quadrilateral ABCD is a parallelogram. We will join A and C, which produces a diagonal AC which cuts this parallelogram into two triangles, triangle ABC and triangle CDA. Now let's try to prove it. In triangle ABC and triangle CDA, we have angle BAC equals to angle DCA, or angle 1 equals to angle 2, as they are alternate angles. They are alternate angles of the transversal AC which cuts the parallel lines AB and DC. Next, we have AB equals to CD as given in this theorem. Further, we have a common side as AC. Therefore, AC equals to CA in these two triangles. Hence, by the rule SAS, that is side angle side rule, we can say that these two triangles are congruent. Therefore, triangle ABC is congruent to triangle CDA. Hence, if these two triangles are congruent, their corresponding parts are always equal. Therefore, angle DAC equals to angles ACB, or angle 3 equals to angle 4. But these angles are alternate angles also. Alternate angles of the transversal AC which cuts lines AD and BC. Therefore, we can say AD is parallel to BC. We also have that AB one side is parallel, so AB is parallel to CD. It's given in this theorem. Now, seeing that both the opposite sides are parallel, hence this quadrilateral is a parallelogram. Therefore, this theorem is proved. Next theorem is 8.9, which is also named as Midpoint theorem. The line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half of it. This had appeared in 2010 CBSE CC exam. Solution given. We have a triangle ABC in which E and F are the respective midpoints of sides AB and AC. We have to prove EF is parallel to BC and EF is half of BC. Construction. We will draw CD parallel to BA, which intersects EF produced at point D. Now let's try to prove it. Side BA is parallel to side CD and AC cuts them. Now angle BAC equals to angle FCD, or angle 1 equals to angle 2, because they are alternate angles of transversal AC cutting two parallel lines BA and CD. Now in triangle AFE and triangle CFD, we have angle BAC equals to angle FCD, or angle 1 equals to angle 2, as we have proved above. And we have AF equals to CF, which is given in this theorem. Next, angle AFE equals to angle CFD, or angle 3 equals to angle 4, because they are vertically opposite angles. Hence, by the rule ASA, which is angle side angle rule, these two triangles are congruent. Therefore, triangle AFE is congruent to triangle CFD. Hence, if these two triangles are congruent, then their corresponding parts are equal. Therefore, EF equals to FD. Similarly, AE equals to CD, which are also corresponding parts of congruent triangles. But AE is equal to EB, as E is the midpoint of AB, which is given in this theorem. Therefore, CD equals to EB, and also BE is parallel to CD. Looking on this, we can say that a pair of opposite sides of a quadrilateral is equal and parallel. Thus, quadrilateral BCDE is a parallelogram. Now, if this quadrilateral is a parallelogram, therefore EF is parallel to BC, as they are opposite sides of a parallelogram. Also, BC is equal to ED, as opposite sides of a parallelogram are also equal. Now, ED equals to EF plus FT. Therefore, replacing in the earlier statement, we can get BC equals to EF plus FT. But we have proved earlier that EF equals to FT. Therefore, in the earlier statement, we can say that BC equals to EF plus EF, that is, BC equals to 2EF. In other words, EF is half of BC. Hence, this theorem is proved. Next theorem is 8.10. It is converse of midpoint theorem. The line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Solution given. A triangle ABC in which E is the midpoint of AB and line L is parallel to line BC. We have to prove AF equals to FC. That is, F is the midpoint of AC. Construction. We will draw CG parallel to AB, intersecting line L at point D. Now let's try to prove it. We have CG parallel to BE and line L parallel to BC, which are given. Therefore, quadrilateral BCDE is a parallelogram because opposite sides are parallel. Therefore, if this quadrilateral is a parallelogram, then opposite sides are equal also. Therefore, BE equals to CD. We also have AE equals to BE, as E is the midpoint of AB, which is given in this theorem. Thus, by statement 1 and 2, we can have AE equals to CD. Now, in triangle AFE and triangle CFD, we have AE equals to CD as proved above in statement 3, and angle BAC equals to angle FCD, or angle 1 equals to angle 2, which are alternate angles of transversal AC which cuts the two parallel lines AB and CG. Also, angle AFE equals to angle CFD, or angle 3 equals to angle 4, which are vertically opposite angles. Hence, by the rule ASA, that is angle side angle rule, we can say that these two triangles are congruent. Therefore, triangle AFE is congruent to triangle CFD. Now, if these two triangles are congruent, then their corresponding parts are always equal. Hence, AF equals to FC. Hence, this theorem is proved. Next theorem is 8.11. The sum of all the four angles of a quadrilateral is 360 degree. Solution given. A quadrilateral ABCD. We have to prove angle BAD plus angle ABC plus angle ADC plus angle BCD equals to 360 degree. Construction. We will join B and D, which produces a diagonal of this quadrilateral, and it divides the quadrilateral into two triangles ABD and BDC. Now let's try to prove it. Since the sum of the angles of a triangle is 180 degree, we have angle BAD plus angle ABD plus angle ADB equals to 180 degree. In other sense, angle 1 equals to angle 1 plus angle 2 plus angle 3 equals to 180 degree in triangle ABD. Next, angle BCD plus angle CBD plus angle BDC equals to 180 degree, or in other words, angle 4 plus angle 5 plus angle 6 is equal to 180 degree in triangle BDC. On adding above two statements, we will get angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 equals to 360 degree. Now, as we know that angle 2 plus angle 4 is equal to angle ABC, and angle 3 plus angle 5 is equal to ADC, therefore we will replace these two angles with the sum of these two angles. Therefore, we will get angle 1 plus angle ABC plus angle 6 plus angle CDA equals to 360 degrees. In other words, angle BAD plus angle ABC plus angle ADC plus angle BCD equals to 360 degree. Hence, this theorem is proved. We have reached end of part 1, chapter 8, Quadrilaterals and Parallelograms. I hope you have enjoyed this video and took the best use of it. You can mail me on info@bobsmartclass.com or call me on 9818387955 and ask your queries. Thank you.